Hi. Hi, Dave here again. So last time we made a massive regex pattern that recognized every word in Moby Dick. So here today we have the complete works of Shakespeare. We're going to tokenize this into individual words, and we're going to do the same thing. So this video we're going to adapt the script that we used to make the massive Moby Dick regex pattern, and we're going to make a massive regex pattern that matches all the words in the complete works of Shakespeare. So here's the table of contents. This is the file. Okay. So these are the, this is the script that we'll need. So I'm going to copy the Moby Dick script. Okay, let's edit the script, the file that I just made. Okay. Okay, so I think actually that should be it. That should be all we need to edit. We could change the names of some of these variables, but the name of the file is the real thing that we need. Oh, and I suppose the output file we should write it into. Let's see, where am I doing that? I don't even remember in this script. Oh yeah, right here. So we'll change this to different. Okay, Shakespeare. There we go. Okay. So let's try this. Node Shakespeare regex JS. Okay. And I'll say, even though we get quick compile times, I think always on the second word or so, these massive regex patterns take a long time to solve, and then the rest of them go very quickly. My hypothesis is that it's because the regex engine in JavaScript, I'm pretty sure it's a backtracking engine, and so with backtracking, there are all sorts of, I think, like memoization or other optimizations that it does, and I'm thinking that must be the pass where it makes a lot of those, caches a lot of that stuff or something like that. So anyways, it would be interesting to also run this test with another regex engine like RE2. Maybe that's for a future video. Okay, let's see here. Moment of truth. Did we make it? All right, look at that. 973,368 matches out of 973,368 words. It took 216 milliseconds to compile the logical expression, to translate that logical expression into the pattern string, 120 milliseconds, and then about 10 milliseconds to generate the regex object. And here are all the words that had out of range code points. You can see they're mostly typographic apostrophes, and so not a big deal. And let's take a look and see how big is that pattern file. Okay, so we can see here in the last line is the regex for Shakespeare, which is 183 kilobytes compared to 116 kilobytes for the complete works of, for Moby Dick. So actually, that's a testament to the power of the prefix compression with trie-regex patterns. The complete works of Shakespeare. Let's go through here actually. And Shakespeare TXT 5.4 megabytes versus if we go up to the source text for Moby Dick. Moby Dick.txt 1.2 megabytes. So, 4 to 5 times more longer of a source text, but actually the pattern to recognize them all is not by that big of a factor, if that makes sense. Anyways, so let's take a look at the pattern. Here it is. Cool, huh? Anyways, thanks for watching.